Hi, welcome to your lesson on an introduction to parabolas, and we are going to focus on standard form parabolas today. As you may know, a parabola has this kind of shape. We've been working with quadratic equations. When graphed, quadratic equations create this shape or this curve, and it is called a parabola. This is a very big idea in mathematics. That's why we begin the SL course with quadratics as one of our first units. For the first part of this video, just watch. Do not feel the need to take any notes. I'll let you know when to start taking notes on the page which has been provided to you. Let's look at these examples first. Here are some quadratic expressions, and here are non-quadratic expressions. As you know, quadratic must have a power of 2 or squared as the largest exponent on any of the terms with x in them. Over here, you notice there's a power 3 here. That's a cubic expression, not quadratic. This one here is quadratic. This is also quadratic. This is quadratic. And this one is also. So notice the order here doesn't matter. As long as we have a y squared and here an m squared, a w squared, something squared. On this side, it was cubic. This one has no squared exponent, therefore it's linear. This one does have x squared, but it also has another variable, so that's not a quadratic. This one has a fourth power, quartic, so that's not quadratic. And this one just has a constant squared, not a variable squared, so that is not a quadratic either. Now let's talk about parabolas. Again, parabolas are the curve or the thing that is graphed on a coordinate plane when we have a quadratic equation. So a quadratic equation has this form: y equals ax squared plus bx plus c. The a, b, c represent the coefficients here in front of x and x squared. The c is the constant. This is called standard form. There are other forms as well. Note that a, b, c are constants and a cannot be 0, because if a was 0, there would be no x squared term. It would no longer be a quadratic. And the highest powers must be 2. All right, here's a real life example of a quadratic curve or parabola. Parabolas are very useful when studying all kinds of things on planet Earth because gravity makes all projectiles or objects thrown above planet Earth or launched above planet Earth follow this path. Here's another example of something shaped in a parabolic shape. Here's another parabolic shape. Often suspension bridges use the ideas of quadratics and parabolas. Here we have as well another real-life example, and another one as well, building in St. Louis. And there's a basketball shot once more. So let's look at these. These are all quadratic equations. I would like you to try to write these in standard form. This one is already in standard form, but what are the a, b, c values? This one also. This one you may have to multiply here to write into standard form. Your job again is to find a, b, c values for all three. So hopefully in this first one you noticed it's out of order here. When you rearrange it, your a value is the coefficient here. That's -1, b is 3, and then c is that constant at the end, the 4. Here, we only have two terms, but it's still quadratic. Let's see what our a, b, and c are. A is the number in front of x squared, which is 1. We have no b term because there's no x term, and we go right to the constant at the end. So that's our c value. Notice b for that reason is 0 then. We have no x term, therefore b is 0. And in this one, when you multiply it out, this thing expanded here becomes this. Then you can multiply the 3 through that, distribute the 3 through all of it, and then we have our a, b, and c values there. Okay, when graphing quadratics, again, when you have a quadratic equation such as this, and you graph it, it will be a parabola. The most basic way of graphing is just to make a table of values, right? I've taken x values between -3 and 4, and I'm going to find the corresponding y values. So basically, take the -3, substitute it in here and here. -3 squared is 9, minus -3 will be like adding 3, so that's 12, minus 2 is 10. So y value is 10 when x is -3, and that point can be plotted on here. If you continued on in the table that way and put all these points in here, you would get these y values. Then you can just plot those points as such. All right, here's -3, 10, here's -2, 4 right here, and then -1, 0 is here, and so on and so on. So there's a parabola, but we don't always want a graph making a table of values, so there's going to be shortcuts we're going to look at. But for now, know that this will always work. It will get you the graph you need. Important points on here. There are two x-intercepts, one here, one here. We've looked at that a little bit. There doesn't always have to be two. There can be 1 or 0 x-intercepts as well. Over here, we have the y-intercept right here, y-intercept. It's where the parabola intercepts the y-axis. And here it says labeled as the turning point, but this is more commonly called the vertex, all right, where the graph changes direction. So parabolas have these key points, two x-intercepts, a y-intercept, and a turning point or vertex. Let's take some notes now, so please grab the notes page you were given. Let's add to that. I'm going to use Desmos while doing this. I would suggest you do the same thing if you have your laptop handy in front of you right now. Let's open up Desmos. Start graphing on here. And we'll look at different properties of parabolas. First, we're going to look at what happens when you change the a parameter. So in other words, again, a parabola, right, has your a, b, and c values. We're going to look at what happens when you change the a value. So first, we're going to look at what happens when a is greater than 0. So in Desmos, I'm going to enter in, start off, I'm going to put in a basic parabola. Remember when we were transforming functions, this is called your parent function. We're going to see what happens when you transform that. So now I'm going to put in a standard form. So ax squared plus bx plus c. So there's my standard form parabola. And I'm going to hit all here for sliders. If you've used this on Desmos before, you'll see it's useful. These coefficients can be changed now. So I can change what a is. And you can see the blue one is my new parabola. And it's changing as I change a. So let's see, what was the question again? What happens when a is greater than 0? When a is greater than 0, so right now a is greater than 0. Look at the blue parabola. I'm going to zoom in a little bit. Change this to projector mode as well. When a is greater than 0, the parabola seems to always be opening upwards. Let's see what happens if I make a less than 0. So here I'm at almost close to 0, and then a is less than 0. Notice the parabola now is pointing downwards. So when a is less than 0, it goes down. When a is greater than 0, it opens up. So that is called concave up. A parabola that looks like this is called concave up. All right. And here I drew another example, because on these graphs, you'll see in the notes, these are your parent function. This is y equals x squared. And we're going to add one extra parabola to each one just to show what happens. So here's my example of that. And basically, when the parabola opens up, it's called concave up, and that happens when a is greater than 0. Let's look at the next thing here. What happens when a is less than 0? We already kind of noted that. Let's see, when a is less than 0, the parabola opens down. All right, so when a is less than 0, it is concave down, and we can also say it opens down. And here's an example of a parabola like that. So make sure you've added those notes and add an extra parabola to see what's going on here. Let's go to the next bit. Next thing we're going to check is what happens when the absolute value of a is between 0 and 1. Basically, that means what happens when a values are between 0 and 1, but not just on the positive side, also on the negative side. So the absolute value tells us we're looking between 0 and 1 on the positive and negative side. So I'm going to change something on here to help us with that. Notice these numbers here. Right now I can make a go all the way to 10 or negative 10, but I'm trying to see now a values between 0 and 1 on the positive and negative side. So I'm going to click on that. I'm going to put negative 0.9. Negative 0.9, that's fine. And here I'll put positive 0.9. That means when I slide the a, it's now only going to have a values between negative 0.9 and positive 0.9. And the step here tells me how much it's going to change as I slide it. So I'm going to put 0.05. Now, when I move this, I can only see a values basically between negative 1 and 1, right? But not quite negative 1 and 1. And let's see what happens. Zoom out a little bit to see this better. And I'm also going to change the b value. I'm going to make the b value 0. And the reason for that is I want this parabola to be sitting in the same place in the middle here as the original parabola. So what do you notice about this parabola, my blue one, and the original, when a values are between 1 and -1? Let's slide this down as well and be more clear. There, make C 0. All right, now I'm going to do this again. All right, what do you notice about the blue parabola compared to the red one? Well, I hope you can see that no matter what, see, when I go all the way here, almost to 1, it's slightly wider than the original. I can't get it to be thinner because I'm keeping a less than 1. And on the negative side, it's pointing down. We already looked at that, but it's also wider than the red one would be. So that's what a values between 0 and 1, basically decimal values of a that are less than 1. They make the basic parabola wider than the original. So I'm going to draw an example here. When a is between 0 and 1, it is wider. Right, let's look at now, what if the absolute value of a is greater than 1? In this case, we're looking for a values that are bigger than 1 on the positive and negative side. So now, change these again. -10 and 10. All right, let's slide that. Now, when the a values are greater than 1, there a is greater than 1. Look, now the blue parabola is inside the other one. It's thinner than it, all right? And then let's go on the negative end. Negative side, when the a values are greater than -1, it's also thinner on the, but pointing down. So when a values are greater than -1, the parabola is actually narrower than the basic parabola. So, oh, let's see. And there's the example of that one right here. I've drawn a narrower one. All right. And finally, when a is 0, then the x squared term is eliminated, thereby changing the parabola into a line. Let's see that here. When a is 0, what happens to the blue one here? There. A is 0, and it turned into a line. All right, because the x squared is gone. It's no longer a parabola. It's just a line now. All right, next. What happens when you change the c parameter? First thing we're going to check is what happens when c is greater than 0. So here's c, and I'm making c a positive number. What do you notice about the parabola? It is just rising up, right? So that actually we should already recognize that from before when we were doing transformations and we added something to the function. So here we have x squared, and now we're adding just a number to it. Imagine adding c here, plus c. That would be a vertical translation, right? And that's exactly what's happening here. The parabola is moving up. When it's positive, it's moving up. So then the parabola translates vertically in the positive direction. An example of that would be this. I took a parabola and it went up. All right, now what if c is less than 0? So now I'm going to make c a negative value. When c is less than 0, the parabola drops down below the x-axis. It's going down. So when c is 0, it's sitting right there with the parent parabola, and then when c is negative, it translates down. So when c is less than 0, the parabola translates in the negative direction. Important thing to note is that the c value gives you the value of the y-intercept. So let's see here. Our c value is -5.2, and if I click here, notice the y-intercept is -5.2. I can also move that up. Now my c value is 3, and the y-intercept here is 3. Even if I change the other values here, now I'm going to shift the parabola over a little bit. So now the parabola is kind of shifted over to the left, but still this value here is 3, which is my c value. And if I shift it down, now let's see over here. Y-intercept is -2.4, and that's what my c value is. All right, so c value tells you your y-intercept. In this case, I move this parabola. There's my -2, so that means the c would be -2. And final thing, this is an extra little challenge. You're not really required to know what changing the b parameter does, but let's check it here just so you see. I have a parabola. I'm going to change the b value, and look at the path that the vertex of the parabola is following. The vertex of the parabola, when I change the b value, follows a path that is actually a reflection of the original parabola in the negative direction. So that's pretty neat that it follows that. There's more details to that. There's not much time left in my video here, but here it is. The parabola is following that path. I'll fill in the rest here. You can pause the video and check it out. and this one as well.